Now in C++ we have two bitwise shift operator. First one that we have is called as left shift operator, and we also have right shift operator. So in this video we are going to see how the left and right shift operator basically works, and we will see some code snippet and we'll see how we can use them in actual code, right? So let's quickly get started, and let's start with the left shift operator. Let's see how the left shift operator actually operate on the bits. All right, so for this we'll take few examples. All right, so let's consider an example. Let's say we have a number in decimal. Let's say it is 1. Okay, so this is the first example. Let's take one more example. Let's say we have a number, let's say it is 3 in decimal. Okay, now what we'll do, we'll quickly find what is their binary equivalent. Okay, so let's find what is the binary equivalent of 1. So binary equivalent of 1 is nothing but 0 0 0 1. So basically I am writing binary equivalence in 4-bit binary format. All right, similarly let's quickly write the binary equivalent for 3 in 4-bit binary format. So it is going to be 0 0 1 1. So this is binary equivalent for 3. Okay, now let's first see the left shift operator. The left shift operator is a binary operator. Okay, so as it is a binary operator, that means it takes 2 operands. Now what are these 2 operands? The first operand that this operator is going to take is going to be the actual number or actual variable or actual constant on which you have to perform the shift operation. Okay, and the second operand is going to be by how many places you want to perform shift. Okay, so in this case the number on which I have to perform the shift operation is 1, and let's say I want to perform the shift by, let's say, 1 place. So in this way you will write the code, or you will write the expression. Let's say you want to perform left shift, let's say on 1 only, but let's say this time you want to shift it by 2 places to the left. Then in that case you will write the expression in this way. You will have to write 1 followed by left shift operator. So basically that means we want to shift the bits of 1 2 places to the left. This is the meaning of this expression. Similarly in this case the meaning of the expression is we have to shift bits of 1 position to the left. Okay, so let's see what it's going to return, or what is going to be its output. So in this case, as we are shifting the bits 1 position to the left, let's quickly shift the bits 1 position to the left. Okay, now in this case we have 4 bits format. Okay, so this 0 will go out, right? If we shift it by 1 position to the left, then it will go outside of the 4 bits. So this 0 will come at the first place. So at the first place we will have 0. Then this third 0 will come at second place. So on the second place we will have 0. Then this 1 will come at third place. So basically we are shifting every bit 1 position to the left. Now let's quickly see what will happen in this case, in second case. See, in second case this 0 will go out. Similarly this 0 will go out because we are shifting by 2 places. Now this 0 is at third position, so now this 0 will come at the first position because we are shifting by 2 position to the left, right? Similarly this 1 was earlier at the 4th position, now it will come at the second position. Okay, I missed it over here. This is 0 followed by 1. Okay, now just understand we have 4-bit binary format initially, and when we are performing the shift operation, actually some bits are getting deleted, right? So if we shift the bits 1 position to the left, then there is going to be a room at the right hand side for 1 bit. Similarly, if we shift our bits to 2 position to the left, then there is going to be a room for 2 bits on the right hand side. So you can observe here, in case of the second case or second expression, we have a result, and in that we have only 2 bits. Okay, so in this case what we are going to do is we are going to append 2 zeros at the end, and in this case we are going to append 1 0 at the end. So the answer of left shift of 1 by 1 position is nothing but 2, and answer of left shift of 1 by 2 position to the left is nothing but 4. So basically what I'm doing is I'm converting this binary back to decimal, and I'm getting answer as 2 followed by 4. So I hope you are very clear with the idea of how the left shift operation is actually working. Okay, now let me again explain you how the left shift operation will work on this example. Okay, so let's consider, let's say I want to shift this 3, let's say one position to the left. Okay, so let me show you how this will work. So this 3 is basically represented in binary in this format. Let me draw it in box format so that it will be more clear to you. Okay, so it will be like 0 0 1 1. Okay, now let's see what is going to be the result. So let me draw one more box, and in that let me initially have it as empty. Okay, now as we are shifting bits to the one position to the left, so this 0 will go out of the frame. Now this 0 will come at this position, so this 0 will occupy this position, this one will come over here, this one will come over here. Now one place on the extreme right side is right now empty. Okay, so with which value we'll fill this place? We'll fill this place with value that is 0, and the resultant answer that we are getting is nothing but 6. So if you convert this number, then this number is nothing but 6. So if you perform left shift operation on 3, and if you are performing left shift by 1, then the answer that you are getting is 6. Okay, now can you observe any pattern from these answers that we are getting? Just try to observe it and try to find out a pattern that we are getting out of these answers. Okay, you will get some pattern out of it. If you will observe very carefully, when we are performing left shift operation on 1, and when we are doing left shift by 1, so it is equivalent to, when we say left shift of 1 by 1 position, it is equivalent to 1 multiplied by 2. Similarly, when we are performing left shift operation by 2 positions to the left, it is equivalent to 1 multiplied by 4. 1 is nothing but our actual number on which we are performing the left shift operation, and from where we are getting this 4 we are getting from how many places you are shifting. Okay, so basically let me write it in a general way. When you are performing left shift by n, okay, so let's say, and the number on which you are performing the left shift operation is, let's say, x. Okay, so let's say you are performing left shift operation on, let's say, x with n places. Okay, so the answer that you are going to get is going to be x multiplied by 2 raised to n. I hope you will keep this formula in your mind. This can help you in your MCQ test. So when you will perform left shift operation by n places on x, the output that you are going to get is going to be x into 2 raised to n. It's very easy, very easy. Okay, so you can observe it over here. Let's quickly see whether this formula is actually working for 3 as well. So just try to see. See, in this case, in case of 3, our x is 3, and we are applying left shift operation by 1 place, so it is going to be 2 raised to 1. So if we'll calculate, it is basically nothing but 3 into 2, so that comes out to be 6, which is equivalent to the answer that we are getting. So we can say that left shift by 1 is equivalent to multiplication by 2. We can say left shift by 2 is equivalent to multiplication by 4. Left shift by 3 is equivalent to multiplication by 8. Similarly, left shift by 4 is equivalent to multiplication by 16. Okay, so this is the observation that you should keep in your mind, because whenever you are getting any MCQ question, then you can make use of this observation, and maybe you will get answer a little bit quickly as compared to the other candidates, and obviously this will help you. Alright, so now I hope we are clear with how the left shift operation is basically working. So let's quickly see how the right shift operation works. Okay, so let me just clear my whiteboard and let's see how the right shift operation works. Okay, so for the right shift as well, we'll take the same example, that is 1 and 3. Okay, we have already converted them to the binary. Now let's quickly see how the right shift operator basically works. For our example, let's say I want to perform right shift of 1 by, let's say, 1 position. Similarly, let's say I also want to perform right shift of 1 by, let's say, 2 positions. And for 3, let's say I want to perform right shift of 3, let's say, by 1 position. Now, and let me take one more example. Let me take example of, let's say, some negative number I want to take. So let me take an example, let's say, of -4. Okay, so -4 in decimal. Now I want you to calculate what is the value of -4 in binary. Okay, so I want answer from you. Just pause the video here and try to find what is the binary equivalent of -4. I'm going to tell you answer anyhow. How we convert negative number to binary? It's quite easy. See, just convert 4 to binary. So what is the 4 in binary? It is nothing but 0 followed by 1 followed by 0 0. Okay, this is 4 in binary. Just take 1's complement of it. What is 1's complement of it? It is 1 0 1 1. Then add 1 to it. So if I will add 1 to it, then 1 plus 1 is going to be 0, then 1 carry, then 1 plus 1 is going to be again 0, then 1 carry, then 0 plus 1 is going to be 1, and then this one is going to come here as it is. So binary equivalent of -4 is nothing but 1 1 0 0. Now let's apply right shift on this as well. So let me write right shift of -4 by, let's say, 1 position. All right. Now let's quickly see, let's try to find out what are their answers. Okay, so right shift operation, what it will do basically, as it is, its name is suggesting, it will shift the bit 1 position to the right if you are applying right shift by 1 operation. Similarly, if you are applying right shift by 2, then it will basically shift bits 2 position to the right. All right, so let's quickly do that. So in this case basically what is going to be the answer? The answer is going to be 0 0 0 0. Why it is 0 0 0 0? Because this one is shifting to the right, so it will go outside of the 4-bit frame. All right, now these 3 zeros will take their position. All right, and on the 4th position I am appending 0 because the 4th position on the left side is now getting empty. So that's why I am appending 0 to the 4th position, and the answer that I am getting is 0 0 0 0. Okay, so what is it? Is it in decimal format? It is nothing but 0 in decimal. Now let me show you how the one right shift to the 2 is going to work, or what is going to be the answer for 1 right shift by 2. Okay, so let me just draw it in a box format for the better understanding. So 1 is nothing but 0 0 0 1. Okay, if you will shift it to the right by 2 positions, then in 4-bit box format the 1 will go out, obviously, then 2 will also go out because we are shifting by 2 position to the right. Then this 0 will come over here at the extreme right place, right? Extreme right place. It will come over here. So let me write 0 over here, and this 0 will come over here. So here it will be 0. Now 2 places on the left hand side are getting vacant. So here we will fill with 0 0. So what is the answer that we are getting for this? It is again 0. Now let's see what we get as the output for 3 right shift by 1. So in case of 3 right shift by 1, the answer that we are going to get, let me write it directly. So this 1 will go outside of the 4-bit frame. So the answer that we are getting is 0 0 1. And on the extreme left hand side, 1 position is getting vacant. So we are going to fill that position with 0. Okay, so this is nothing but 1 in decimal. Now here is very important rule about the right shift operators. It is very important rule about the right shift operator. See, in these cases, whenever the positions on the left hand side were getting empty, I was filling them with 0. But what if I will say, not every time you will have to fill these positions with 0. Sometimes you will also have to fill these places with 1. Let me quickly repeat. Sometimes there are some conditions in which cases you will have to fill the left positions which are getting vacant with value as 1. Okay, let me tell you in which cases you will have to fill the positions on the left with value as 1. So the condition is basically in this case, or this is the condition where you will have to fill the value or the position which are getting vacant on the left hand side with value as 1. So in this case, whenever you are performing right shift operation on -4, let me just show you in a bit format. So the number is right now 1 followed by 1 followed by 0 followed by 0. Okay, now whenever you will perform the right shift operation by 1 position, so what is going to be the resultant frame? So this 0 will come out, right? This 0 will come over here, this one will come over here, this one will come over here. Now here the one place on the left hand side is getting vacant, but we will not fill this place with 0. Why we will not fill this place with 0? We will fill it with 1. Why we are filling it with 1? Because this is a negative number. Always remember, in case of negative numbers, whenever the places on the left hand side are getting vacant, you will have to fill the boxes on the left hand side with value as 1. Whenever the number is positive on which you are applying the right shift operation, then in that case, whenever the places on the left hand side are getting vacant, you will have to add 0 to them. Okay, so in case of negative number, you will have to add 1. In case of positive number, you will have to add 0. That's it. It's quite easy, right? So I hope you will remember this thing. And let's see in case of left shift operation, we have actually formed a generalized formula. All right, and from that formula we were able to predict what was the answer. Okay, what is the answer of applying left shift operation? Let's try to find what is the generalized formula for right shift operation. The generalized formula for the right shift operation is also very easy. So whenever we perform a right shift operation, let's say on number x, let's say by position n, whenever we are performing right shift on x by position n, then the output that we get is nothing but x divided by 2 raised to n. Let's try to apply this formula on these numbers. Whenever we are writing one right shift by 1, that is nothing but 1 divided by 2 raised to 1, that is 2. So if you find answer of 1 divided by 2, it is nothing but 0. Similarly, when you are writing one right shift by 2, that basically means 1 divided by 4. So if you do 1 divided by 4, the answer is 0. When you are writing 3 right shift by 1, it is nothing but 3 divided by 2. Because 2 raised to 1, we are right shifting it by 1 position. So 3 divided by 2 is nothing but 1. Okay. And similarly, in case of minus 4, when you are right shifting it by 2, when you are right shifting it by 1, the answer that you are going to get is going to be minus 4 divided by 2. It is nothing but minus 2. Okay, so I hope you are very clear with a generalized formula for the right shift operator. Now let me quickly show you how you will write this right shift operator and left shift operator in the code. Okay, so for that, let me just clear my canvas and let's quickly see a simple small code snippet about the right shift and left shift operator. All right, let's quickly see a simple code snippet. So let's say I have a number, let's say, or I have a variable, let's say a. So let me write int a, and let's say it contains a value, let's say 5. Okay, now let's say I want to apply left shift operation on it. So let me create another variable, let's say int b, and let's store the result of left shift operation on a in b. Okay, so let's say I write left shift a, let's say by 2. And similarly, if you want to perform right shift operation on a, then let me write another variable c, and I can write a right shift, let's say by 1. So in this way, basically you will have to write the syntax. Always remember, the right shift and left shift operation are not going to change the original operand bits. It is not going to alter the original operand. Okay, so let's say after this statement, when you will see out or when you will print a, the value of a is going to be the same. It is going to be 5. It is not going to change. Doesn't mean that as you are applying left shift operation, that means the original bits of the variable a are going to shift, right? It's not like that. It is just going to give you the result, and the result you can store it in some variable, or you can directly use it in some other expression, or maybe you can print it directly. All right, so this thing is very important. You have to remember it. The left shift and right shift operators do not actually alter the original operand. They will just do the computation and will return you the result.